Good afternoon, everyone. As you can see from this slide, it took mobile phone 16 years, internet 7 years, and Facebook 4.5 years, but to reach 100 million users. But ChatGPT just took 2 months. Isn't that incredible? And again, I wanted to add some animations here, so I could have asked you how many months it took, but unfortunately, the changes were done last minute, and you got the answer ready-made, right? So I think just want to share that. Again, the important thing here is that we have experienced a diffused explosion in ChatGPT, right? So earlier the slope was a gentle curve, but as you can see with ChatGPT, it's almost like a vertical line right now. So my name is Devin Wagle. I'm Partner Cloud Solutions Architect with Microsoft and work very closely with MongoDB. And Paul and I am going to show how AI and GenAI come together with MongoDB Atlas on the cancer use case. But I'll ask Paul to introduce himself first.
Hello, yes, my name is Paul Leary. I'm a Senior Solutions Architect at MongoDB on the partner team, and I'm exclusively involved in working with the Azure partnership, and work very closely with Devins and to help out and assist and enable on those migration technologies.
Awesome, thanks Paul. So let's jump into the presentation. What we want to go over is that we want to show you the underlying Azure AI and MongoDB services involved before we go to the demo. So it's not been an overnight journey, right? History of AI dates back to 1950. And as you can see that Microsoft has been involved for many, many years in this AI journey. So we have heavily invested in AI with our partnership with OpenAI back in 2009. And we understand that right now generation AI is at a turning point where, this is like every minute things are changing at a fast pace, right? And you have to keep track of these. So it gets very, very daunting. So what we have done is we have come up with tools and services that help customers digest all this data quickly. So let me go to the next slide now. Again, this is a very busy slide, but what I want to highlight here is that Azure AI service that you see here is a service that is designed to make it easy for developers to deploy AI-enabled applications without the expertise being in AI, right? They don't need to be an expert in AI. So one thing I would like to quick here, which we are going to talk in our demo, is our Azure OpenAI service. So what Azure OpenAI service does is it enables developers to deploy scale AI-enabled applications with the Azure capabilities of scalability, security, and compliance. On the left-hand side, you can see MongoDB Atlas, which in this case is depicted as a transactional workload. And on the right-hand side, you can see Microsoft Fabric and Azure OpenAI. So for those of you who don't know what Microsoft Fabric is our unified analytics platform that gets your varied data estate together, and you can run analytics on top of that and generate insights in seconds. It is based on a OneLake, which is a data lake as a service available to you. And the key takeaway here is that you see your transactional systems on the left and the analytic systems on the right, and they need to work synergically so that for the needs of the modern applications, they can exchange data in near real time. So let's double click on what Microsoft Fabric is, right? So like I said, it's a complete analytics platform. It is based on OneLake, which is open at every layer. And again, you get this built-in system of a data lake available in your Microsoft tenant. It is based on open format of Delta Parquet. And there is just one copy of it, right? So you have all analytical services I'll show on the next slide, which you can utilize, and the data sits in just one lake. And whether you are Spark user, your SQL users, you can connect to that data and run queries on top of that. Fabric also integrates with AI Copilot, so you can accelerate your productivity and generate insights in seconds. Again, and Fabric also has the same enterprise-grade security that we have with Microsoft Azure, so that you can get governance and security all in one place. So again, this might look little complicated slide, so let me just break it down for you. So like I said, imagine Microsoft Office 365 and Fabric is very similar. That Microsoft Fabric is what Office 365 is for data. So similar to you have Microsoft Word, PowerPoint, and Excel in Office 365, Microsoft Fabric has these workloads of Power BI, Synapse, Data Factory, and Data Activator, which lets you run analytics on data sitting in one lake. So you can have data from different data lakes, all converge and sitting in your one lake. And then whether you are a user of Spark, SQL, Analytics Service, you can all query that data in one go. All this data is stored natively in one lake in Delta Parquet format, and it's open so that you can access this data with APIs. One thing to call out here is that it provides real separation of compute and storage. And what I mean is that your compute layer is on top of that can scale separately, and you can manage your storage layer and your cost accordingly because they are decoupled. They are truly decoupled in this stage. So I'm going to ask Paul to walk us through the cancer demo that I know you guys are eagerly waiting for. So I'll pass it on to Paul.
So this will be, this application, we're going to do it in two parts. And the reason why is we're going to do, as Devin mentioned earlier, an AI, right? So we're going to be leveraging AI. And then in the second part, we're going to be leveraging Gen AI. And they're very different. There's a lot of conflation occurring between the two, but they're very different. And we purposely did that separation so that we can clearly see the differences in where they can actually synergistically work together also. So what I'll be doing is Leafy Hospital is going to be essentially patients that are awaiting screening. So the cancer screening is for breast cancer, so there's going to be a list of patients. And what we're going to do is we're going to take a patient through a screening and leverage AI and Gen AI technology to be able to diagnose and work through that patient's cancer data journey. So we're going to put in an image request for mammography, right, an X-ray, and then that request will then be sent to an AI model that we wrote on Fabric. We leveraged Fabric's data science to be able to write a model an AI model that can then do a prediction, a score prediction on, it's called a BI-RAD score. So it's a score on whether or not there could be some cause to be able to look deeper into that patient's, perhaps a biopsy or follow-up. And so then the information will also then be stored for future retrieval. That image will be stored in a lakehouse in Fabric. And in Fabric with a lakehouse, you can store table data, you can store files, you can store the format that you want. And then we're going to take those analysis results of the images, bring them back to the application, and then that information, that reporting information will be saved to MongoDB, and then we're also going to take some of that patient data. We're going to do a very, very simple report and quickly illustrate how MongoDB data can be actually used for a report in Fabric Cloud, which is Power BI Cloud. So there's a Power BI desktop that we're very familiar with, but there is a cloud version that we'd like to introduce. So here we have an application. So there's our Leafy Hospital application. And you can see that there's a list of patients, and it's a screening list, as we mentioned earlier. And they're in various states. They have meetings, appointments that have been canceled, some that have been fulfilled. And this is a B campus, so we have it filtered by B campus. And in fact, we're using Atlas search for this filtering. And we can choose whatever radiologist and what patients they're going to be seeing. And there's our filtering that we're doing. So we're going to look at today, so appointments for today. And then specifically, we're going to want to filter on appointments that have been booked but not fulfilled. So we're just going to go ahead here and click the booked feature. And now we've filtered, and now we're going to select a patient. We're going to select Lucia, and we're going to walk her through a screening process. And during that screening process, you'll see us leverage AI technology to go ahead and analyze those individual images in, as I mentioned, an AI model in Fabric using, it's a private preview feature in Fabric, which is an endpoint that you can expose your AI model. So I have my images here ready to go, and I went ahead and clicked on my very first image to go request it. So I'm going to take that image. That image will be taken, will be brought back into the system. And it's a little faint on the screens there, but you can see some various stages. We're going to take that image. We're going to retrieve some metadata from that image. We're then, as I mentioned, upload it for some storage for future uses. And then we're going to then score it and do that BI-RAD score. So that's the phases that that image is going to go through in our system. And so once that returns, what we'll also do is we'll go on to the next image, and then we'll go behind the scenes to see it go further. Sorry, I think we're stuck here. So the video has stopped.
Want me to try?
Yeah. Can you hit it? Oh, there it is. Okay. Sorry, we'll have to catch up to the recording. Okay, so our images have come in. So you see that there's that BI-RAD score that has executed, and then to the left, you see some information that has come in. So there was some of that metadata that we extracted, that we collected, and then we also have that BI-RAD score that we're going to use in the future here for the next step. So what we're going to do is, and so there's that metadata, so we'll go on and take the next image and the other images, but we'll pop over to Fabric, specifically data science area of Fabric. And here you'll see a notebook that we used to write and it's essentially program our AI model and train our AI model so that it can produce that BI-RAD score. And you'll see a variation of sample images that we used to train the model so that, you know, a BI-RAD 3, what does a BI-RAD 3 look like, a BI-RAD 1? And you can see the various syntax that we used and the process that we went through. We won't go into detail into this, but you'll see here that when we ran a test, after we ran a sample test and we had a BI-RAD score, so you see they're all negatives, negative 0.9, 14 and 17. 1 is our highest, so it's propensity to be a BI-RAD 5 in this test example. So if we go back to the application, see all our images now have completed and we have various BI-RAD scores. So clinically what we would do, the radiologist, next steps would be during the process here that would probably want to invoke a biopsy, go ahead and do the biopsy route. So what we can do here is select the biopsy option. And here it is. So now essentially that biopsy image or data can be taken, brought into the system, and then by clicking here, and then now that will also be ran against a classification model, a separate AI model that we wrote in Fabric to then go ahead and extract this information. So it ran against the AI model, and here is our classification. So we'll go ahead and select it here in Fabric and pull it up. So it's got a different type of program that we wrote there, a little different notebook. We use about 9 different parameters to calculate that, that classification score. And again, just quickly scroll through some of the work that we did in order to produce that AI model. And then if we pop over to how we published it. So this is this private preview feature that's going to be introduced in Fabric and that we're leveraging right now. And we have different versions of that AI model that we've exposed. And we can choose whatever version we choose to deploy, and you can test different ones in your testing, for example. And then you can even do comparisons between the different versions. And then, you know, our menus at the top, you can actually download your ML model, you can apply the version, and then you can manage your endpoints and go see which ones are active, which ones are not active. So you can see here how it's really powerful. You can build those AI models in Fabric. You can stand up an endpoint to that AI model, and then you can call it from programs to be able to leverage them. So what have we done here, right? So we've collected some information. We have some mammograms, we have a biopsy, and then naturally, the radiologist is going to want to capture their notes and put their notes into the system. And this is what's going to eventually, the second part of the demo, take us to leveraging those notes and Gen AI. So we have clinical notes here that we can fill out. We have conclusions. We have SNOMED information, which is like the clinical terminology. But what we're going to do just for this exercise, this is what they wouldn't do for real life necessarily, but we're just going to leverage Gen AI to be able to publish some of the data that we want for this demo in order to be able to leverage it further on in our Gen AI. Because what we're going to do using Gen AI, so natural language querying, semantic querying, similarity querying, different synonyms for that process. We're going to go data mine this information and ask it questions in a human-like fashion and be able to get those questions answered. And so this is information, so a clinician could actually use Gen AI in the future, actually help generate some of that documentation, but in this case we just generated it all, so we can have some great sample data to leverage for our Gen AI process. So before I move on to Gen AI, I mentioned that I'm going to do a Power BI report. I wanted to do something really quick. So I've got some patient information, those patients come from different geographical locations. So what I'll do is I'm going to look at that data and actually that patient information, what we can do is we can flip over to the MongoDB database and show you where it's stored. So if I click on that patient table, and there's our collection, there's our document, and I've got a postal code there. So what I'm going to do is I'm going to export, I'm going to use that patient information from Fabric. And the way I'm going to be able to tap into that MongoDB data is I'm going to use a data flow Gen 2. So that's something that exists in Fabric. It's a connector into my MongoDB database. And so I go ahead and instantiate, I want to create a Gen 2 data flow. And I'm just going to get data from another source as opposed to the ones they had there. I'm going to choose MongoDB as my source. So I click on that and there's my connector. So I could fill in this information and that would give me my data flow connector into MongoDB. I already have one that I've created in the interest of time, so we'll just go ahead and leverage that one. So I'll go back into my workspace and close this out, go into my workspace and go through and actually pull up the data flow that I created. I call that data flow patients. So there it is, and that's just the connection information. Nothing else was done. I'm going to go ahead and execute that data flow that I set up, and you can see that it spins up Power Queries. So if you guys are Power BI users and you've used Power BI desktop, you're very familiar with Power Query. So now we're in Fabric. We have our Power Query. This is where you would massage your data to be able to have it appropriate for the report. And in this case, I pointed my report to that data, and there you have the geographic information appearing on various areas of the map. Very simple Power BI report, but just really wanted to demonstrate how you could interoperate, your analytics, your UI-based analytics, with MongoDB data from Fabric. So what we'll do is we'll go ahead and move on and to the next part of our demo, which is now we have this wonderful clinical information that we've from the screening information that we've collected, and we want to go ahead and implement what we call semantic search, right? Natural language search, and RAG, which is retrieval augmentation generation. And what that is the ability to then query your own data and be able to then use a large language model like we have down here. So if we look at the flow, we have our patient portal, we're going to ask a question. That question is going to be in free text, right? Just a natural language question like, what is their medication? What medication are they on? But we need to convert that into a vector, which is what MongoDB understands, or a vector search storage understands and knows how to do this similarity, find things that are semantically similar to what I'm looking for in the database, like medication-based data. I'm going to search the MongoDB database. It's going to come up with results that are based on what I'm looking for. It'll bring up some of the better results based on classification. And then those results will then be taken and aggregated, brought together into a prompt that I'll then use that data to then send to my large language model, like a GPT, right? We're all used to GPT-4. We've done some queries at home. We're going to generate a prompt, send it to Azure OpenAI, and Devin will get into more detail where you can, where you've got a trusted system, a closed AI system for patient type information is very important. That has a lot of governance, and Devin will get into some of those details further on in the presentation, but it'll go to that LLM and then return these rich results. So always better demonstrated. So here we have our patient portal again, our provider portal and our radiologist. And as we saw here, we were in the mode that we had them for booked, but now we want to see fulfilled. And when we see fulfilled, we see Lucia, that we had actually gone through the screening process for her. So now we're interested in pulling up her results and being able to extract some knowledge out of the results that we inputted here. So we have the notes here, we have the conclusions, all that data that we want to be able to ask what we call just kind of natural language questions. So, and what we'll do here is to give you a behind the scenes look at that data. We'll actually go to MongoDB and show you. So those are the clinical reports. So you have a document stored in a collection, and you see all the attributes to that document, but specifically you'll see some of that free text there, right? You've got the conclusions, you've got the notes over there, and got those highlighted there, and then you'll see a vector embedding, right? So that's where we've taken that free text and we've turned that into a vector to represent what a machine can understand and query, and we're going to query against that vector to be able to see the results that you'll see in a minute when I actually start putting together my queries. And there's an example of what a vector looks like. It's a long array of, and I encourage you to go study. It's a several hour presentation on its own just to be able to explain what vectors are and how they work. They're very powerful. But we'll go back to our UI here, and then we'll go ask some questions. And this is where it all comes together. This is where you're going to see all this technology come together. So the first question we'll ask, we'll go ahead and paste the question here, and you see, what is the patient's current condition? That is just natural language question, as if I would ask a doctor. And you know that asking those types of questions in a system today is very difficult to get accurate response, but vector search, RAG, LLM, Gen AI brings it together. And you can see now that I have a nice, concise response through that process that I showed you earlier. Going through that process, going through those technologies gives you that polished response that answers that question. So for instance, I can ask another question that says, are they taking any medications, right? And we can see that no, they're not taking any medications. So this is where MongoDB comes in, and you can add your own data or augment the data. So let's say more data has come in her, let's say there's a chart, and her chart has added information, or more information has come in from another data source, and you now want that included in your chatbot. So here we have, I just created a little sample PDF, and I just have a little data about medication and a little additional information about what that medication's about. And what we're going to do is we're going to show you how to bring that information into your MongoDB data store and then have it available for this chatbot now to leverage for further questions. So we have this little feature built in. Of course, you wouldn't do that in real life. You wouldn't allow this portal to just bring in any document. This would be done by administrators. But what we're going to do is I have that PDF document stored on my drive, and I'm going to just paste in the path to that file. And once I've pasted in that path, I've loaded up that file. So now we're going to go look and see in the MongoDB database behind the scenes what has happened, right? So I'm going to go to my RAG info table. So I'm just going to go highlight that. And you see, and I kept it simple, just one record. Normally you would have hundreds and thousands of records there. But I have that one record, and that was that text that I pulled out of that PDF, and then I vectorized it, right? I turned it into an array of decimals that this machine can understand, and to be able to do these similar comparisons, and then I can ask these natural language questions against this data now that I've now introduced into MongoDB. So what I'll do now is I will go over to the application, move back to that, and we'll close this down, go back to ask a question. So now I'm going to ask a follow-up question and say, are they on any medication now? And we'll see what the chatbot says. And yes, there's that medication that we introduced via the PDF. So it is now searching the patient information and now searching that data that I brought in and augmenting that data so that we can increase, and we can even build on those questions, because now I can ask if there are any side effects of that medication. And you see that really nice, concise, precise answer. Yes, there are, and some of the damages and whatnot. So this, in a nutshell, was kind of an illustration, kind of the art of the possible of what you can do when you have AI working in, synergistically in unison with Gen AI, and the power of these two technologies coming together in this type of scenario. So we return to Devin, and I mentioned earlier that the importance of the different use cases that you can use, and then also the governance of that data that you're sending to the LLM.
Thank you, Paul, for that wonderful demo. As you can see, Paul just demonstrated how Azure OpenAI and Gen AI came together to deliver on a cancer use case. Now, what we wanted to highlight on this slide is that, hey, this was just a use case in healthcare industry, but just planting the seeds here that you can apply this to your own use cases, right? Think about, hey, what can Gen AI do for yourself? So the typical use cases that we have seen customers use Gen AI is to improve productivity, improve customer end experience, and automate workflow processes, right? So again, this is a Gen AI journey that is very recent. So we are here to help you on this journey. If there are any questions that we can help with, we'll be happy to take them after the session so that we can work together on this journey. This is not, responsible AI is not something new for us. We have been working on this for a long, long time. As you can see from this slide, about 8 years ago, Satya Nadella wrote an article in Slate magazine titled The Partnership of the Future, right? So this journey has been going on for a long time, and Microsoft has been innovating in AI as well as responsible AI for many, many years now. So rather than going over the timeline in interest of time, what I wanted to talk about is that, hey, this is a continuously evolving space. We are adapting as the markets are adjusting to the privacy and security concerns that are brought by these LLM models and new technology, and how we can help our customers securely share and deliver this information. So we just looked at the Microsoft responsible AI principles. So they are based on 6 core principles, right? Sorry. So we have 4 core principles, which is fairness, reliability and safety, privacy and security, and inclusiveness. And they are underpinned by 2 foundational principles, which is transparency and accountability, right? So we believe that the development and deployment of AI should be designed by an ethical framework, and these are what we provide with our responsible AI model. So again, in interest of time, we do not have to go into the details, but I can share more information if you guys are interested in that. This is a very important slide. What this talks about, that when you do use Azure OpenAI, your data is secured. Your data is your data. We do not share that information with any customers. We do not use that data to enhance our Azure OpenAI models. So this data is protected, and they run in Azure VNet, which is controlled by the customer. So depending on the customer's classification and privilege on that data, of course, if it is public data, then that can be used to enhance the model, but as long as it's classified as private or secured, that information will not be used to share or enhance the AI models. So last September, we announced a customer commitment, copyright commitment. What this does is protects our commercial customers from defending against copyright claims of using AI Copilot. And lastly, we also added Azure OpenAI service to that commitment. So what it does is, like, provided you follow some technical measures to make sure that there's no infringement on the output, you are covered under this commitment, right? And this will boost the confidence that customer can develop Gen AI models with confidence. So that is what we have. I know we are running short of time, so with that, we come to the end of our presentation. Thank you for your time, and hope this was useful to you. If you have any questions, you can reach out on the email mentioned on the slide. And this is some additional documents, so if you reach out to us, we can share this deck with you as well. So thank you for your time.